Hi everyone, and welcome to this little vectors recap video from the skills that you've been learning over the last week. We are currently looking at two-dimensional vectors. You'll see some stuff on the board already that hopefully you recognise. We're going to do all the questions with the same two vectors. So we've got some vector notation up here talking about two vectors, A and B. And next to those we've got their components. Remember, this is a description of the direction of the vector, and also its size is contained within this information. Okay, so we're going to look at addition, subtraction, we are going to look at multiplication by a scalar, along with how to find the magnitude of these vectors. Okay, so we're going to start really simply with how do we add two vectors when we have them given to us in component form. What we're going to do, it's almost like a little bit of substitution here at the start. We're going to take vector A and replace it with its components. So in this case, its components are 3 and negative 4. And we're going to try and add to that vector B, which has the components negative 5, 12. And the process with components is a bit more straightforward than if we were doing this with a diagram, which you did practice last week as well. And all we do is we take the x component, which is the component on the top, and we're going to add those together. So we've got 3 plus negative 5, which gives us a result of negative 2. And on the bottom here, we've got negative 4 plus 12, which gives me a y component of 8. And there is our solution. Yeah, so if I add A and B together, I get a resultant vector with the components negative 2, 8. Okay, how about subtraction then? When you do this with diagrams, it's a good bit more complicated, but with components, nice and straightforward. Make sure you pay attention to the orders the vectors are in. So we've got B first this time. So we've got negative 5 and 12. And we are subtracting from that this 3, negative 4. Okay, subtraction, I think always a wee bit trickier, so we'll just give it due attention. Starting with negative 5, we're subtracting 3, so moving further down our number line takes us to negative 8 for the x component. And then we've got 12 and we're subtracting a negative here. So remember, when you subtract negatives, we're going to move up our number line, which takes us to positive 16. Okay, and there are the components of B subtract A. Okay, over we go. And we've got two more questions here. Using the same vectors, A and B, same components. This time we want to find out what is the resultant vector's components if we take 2 lots of B and 3 lots of A and add them together. So quite a lot going on in this question. First thing, same as before, we're going to do a little substitution. So we're going to put, in place of the name B, we're going to put its actual component. So in this case, negative 5, 12. And we're going to add on to that 3 lots of vector A, which is components 3, negative 4. And order of operations is maintained when we're doing these vector questions. So we are going to do our multiplications first and our addition afterwards. Okay, so if I do the multiplication, it's a lot like distributive law. The value in front of the brackets gets distributed between both components through the medium of multiplication. So 2 lots of negative 5 is negative 10, and 2 lots of 12 is 24. With the second one, we've got 3 lots of 3, which is 9, and 3 lots of negative 4, which is negative 12. And now we've got a question that looks like question 1, where we're just adding two vectors together. We've got the components of each. So we've got x component to x component, top to top. So negative 10 plus 9 gives me negative 1. And 24, adding a negative. Remember, if we're adding a negative, we're moving down our number line. So we end up at just positive 12 there. So negative 112, the result of taking 2 B's and 3 A's and adding them together. Question 4, some new notation. We've got these lines, these vertical lines on either side of the vector's name, and this means that we want to know its size. Its magnitude is what we call it, and it's how long the vector is. Just up here, I'll quickly draw out what vector A looks like. It has a start point. It goes 3 units along this x-axis, and then the 4 is the length, and the negative is the direction, so it actually goes down 4 units. Okay, and what we are trying to find, so here's the vector here, there's vector A and a diagram. We're trying to find the length of this. And when we do the wee diagram, I think it becomes really obvious what we're doing. We've got a little right angle in here. We're finding the hypotenuse of a right angled triangle. Okay, that should be going on in the background. We're not going to draw out the diagram each time. We've hopefully done enough of these last week that we can see that we're going to take the components from here and we're going to square each of them. Okay, we can keep the sign in for the negative. It's directional, nothing to do with the size, and we'll see how that plays out when we do the calculation. So we take the two components, 3, -4. I like to put brackets around my negatives to remind me what's going on when I square them. We're going to square these. We're finding the hypotenuse, so we add, and this is not the magnitude squared, this is the magnitude, so we have to take the square root of that little calculation. Okay, that looks quite complex, but remember, all it is your two components squared, added, and square rooted. Let's take a couple of lines to work this out. So we've got 3 squared, which is 9. We are adding to that -4 squared, so -4 multiplied by -4, those two negatives creating a positive value, and it's +16. And then we've got the square root of this. 9 and 16 gives me 25. I was quite kind to myself when I made this one up. We get a nice answer of 5 units. We don't know what those units are because we don't know if this vector represents displacement, if it represents velocity, but it does have units. We just don't know what they are, so we're going to just put in units there. Okay, one last question to talk you through. I'm going to come back to the first page. I'm actually going to keep answer 1, and we're going to play about with that a little bit. It's a little bit of extension work. Let's call this question 5. I want to know the magnitude of the result of adding A plus B. Okay, the magnitude of the result of adding A plus B. We do this by, first of all, working out the components of the resulting vector A plus B. What we don't do is we don't take the magnitude of A and add it to the magnitude of B. We don't find the magnitudes of the two vectors independently and add them. We find the resultant vector's components and then find the magnitude of that resultant vector. And the reason I've come back over here is we've got the resultant vector's components in question 1. This is the components of A plus B. All right, so if you were asked a question like this, you would go through the process in question 1 first. You would get your resultant vector's components. Let's just have a quick look at what this looks like. It goes from its starting point 2 units to the left, and then it goes 8 units up. 2 units to the left, 8 units up. So the resultant vector looks like this. This is A plus B, and it has the components -2, 8. Again, we can see our little right angled triangle. We're finding the hypotenuse. We've got a bit of Pythagoras going on. Okay, so this question now no more difficult than the previous question. We're going to take the components, we're going to square them, we're going to add them, and we're going to square root. Okay, we've got -2. Again, I like brackets around those negatives. Squared, we're going to add that to 8 squared and square root our result. -2 times -2 gives me +4 plus 64 square rooted, and this gives me the square root of 68. Not so nice this time. I'm just going to take my calculator. I'm going to type in the square root of 68, and it gets me 8.24621. I'm out of space, so I'm going to round this to 1 decimal place. If you were doing this, I would write down the unrounded answer first and then the rounded answer afterwards. So I get a solution of 8.2, and again, units for the same reasons that I mentioned in the last question. The next video will look at all these same skills except with 3-dimensional vectors as opposed to the 2-dimensional ones we've covered in this video.